but we're gonna sketch x plus 1 over x minus 3. Now, these guys have zeros, just like the ones we were doing before, x-intercepts. All right? But they also have things the other ones didn't. Rational functions have asymptotes because, stop and think about it, if you put an x in your denominator, aren't there going to be things that x can't be? Because you're not allowed to have a 0 at the bottom. So the cannot be's are your vertical asymptotes. X can't be 0. The denominator cannot be 0. So in this particular problem, whatever else is going on, x cannot be 3. Would you agree with that? So that's your vertical asymptote. Asymptotes are lines. Vertical, x equals, they cross the x-axis. Now we actually talked about our horizontal asymptotes before. Does anybody remember? It's actually written on the board right there, but do you remember how we did those horizontal asymptotes, Lauren?
It would be y equals 1 because it'd be the first exponents divided by 2.
Yeah, so do you remember doing that, guys? Like that, I don't know what you want to call it, that motion right there? So that means your horizontal asymptote is y equals 1. Do you also remember when we did these before that sometimes the powers don't match? And when they don't match, you have to put in a 0 for whichever one is missing. So sometimes we had 0x squared over 2x squared. Remember that happening? Oh, unclog those memories. It's all in there somewhere. All right, those are the asymptotes. Now, the intercepts. The intercepts are points on the x-axis, x-intercepts, and on the y-axis, y-intercepts. To find the x-intercepts, you just let the numerator be 0. Because if, for example, in this problem, if I plug in -1, if I let x be -1, what does y end up equaling? 0. Do I get 0 over something? Won't that be 0? So my x-intercept is at -1, 0. My y-intercept happens when I let x be 0. So if I put in zeros for all the x's, let x be 0, what does y end up equaling? -1/3. Now we also, in rational functions, that is functions look like this. This is different. Remember the ones you just did were like x cubed plus 5x squared minus 8x minus 2 or something? Those are nice little squiggly lines. Once you make a fraction out of it, it's going to be full of all kinds of weirdness. These guys can have things called holes. Who remembers where holes come from? Well, it's written right there in case you forgot. Holes come when we can cancel. Now, that happens when you have a problem like this. There, I would have a hole. That is not going to happen in this problem. So this problem has no holes. There's no holes in this problem because nothing canceled out. Okay? So this is it. All of the important stuff is now here, and now you have to draw the picture. Any idea what it looks like? I'll give you a hint. His first cousin is the reciprocal function. What did that look like? That's one of your BFFs. That's the one that looked like this. It had a vertical asymptote and a horizontal asymptote and a curve that looked like that. This is his first cousin right here. So what do you think he looks like? Can you see it right there? where's the other piece?
What part is it in there?
Right here. There it is. That's it. That's a picture of this rational function. So it's like the reciprocal function, except its asymptotes are shifted around because of these numbers in the problem, right? All right, let's look at the next one because it is bigger. I don't think it's necessarily going to be any harder, but it is definitely bigger. What do you think we ought to do first? Oh, yeah. Yep, if it factors, you want to factor it. All right, so how does the top factor?
X plus 1.
Okay, that's easy. How about the bottom? I'm going to pull out a 2 first, that's my GCF. And then x plus 2, x minus 2. This one's going to look different. But let's get all of our important stuff in there first. Will this one have any holes? Nope, we didn't cancel, so we'll do one. I promise we'll do one. This one isn't it. All right, well, what does it have? Does it have any vertical asymptotes? It actually has 2. One of them is at -2, x equals -2. And one of them is at x equals +2. How about a horizontal asymptote? I think it's easier to look back at the original problem. To find the horizontal asymptote, we box in the highest power. Where is that horizontal asymptote? Where is it? 1/2. Y equals 1/2. Everything okay back there? Everybody understand where the 1/2 came from right here? All right, how about x-intercepts? How do we find x-intercepts? Well, we're going to know 0. So what makes our numerator 0? 1 and -1. Those are the same dots on the x-axis that we had in the last unit. What makes these 0? How about a y-intercept? How do I get a y-intercept? How do I always get a y-intercept? Gotta let x be 0. So you can do it here. There's a lot of x's in there. Or you can do it here. If you let x be 0, what do we end up with? Actually, +1/8. Any thoughts on what this thing looks like? Okay, so Jake's going like this. He says, it looks to me like I got sort of a parabola type shape in there. Doesn't that make sense, just based on the points that you got there? But that's only 1/3 of the picture. You've done the in between the asymptotes. Now you gotta figure out what's out here to the right and what's out here to the left. Because there's something out here and there's something out here. Do you have an idea? No idea?
it on the
Okay,
other one?
so Meg, yes, but we gotta be careful. Meg says, maybe we have kind of a reciprocal-ish type curve here. And she's exactly right. Now, let me tell you why she's right. She's right for a couple of reasons. First of all, and you didn't have any way of knowing this, because I didn't tell you before, but see this asymptote right here? Unless there's something really strange about the problem, I mean really odd about it, like it's got radicals or aciditis or something really funky about it. Once you figured out that on the left side of this asymptote, the curve was going down, that means that on the other side of the asymptote, the curve is going to be going up. It isn't going to go down on both sides. If it goes down on one, it's gonna go up on the other. Now, Mrs. Ford did not say that it could never go down on both sides. It can, but not normally. Normally, if it's going down here, it's going up here. Secondly, if I thought it went down over there, what would have to happen right here? What would that be? An x-intercept. And I don't have an x-intercept there. I already plotted where it crosses. So that means, kids, that anything else I draw cannot cross the x-axis. This is it, right here. It can't cross anywhere else. So this is really your only option. Well, what about over here? What do you think's happening over here? Same exact thing. Yep, the same exact thing. You ready for the next one? Here's, I'm gonna go ahead and erase this because we're gonna need more room for this problem. Hopefully you wrote this down or have some sense of it because we're moving on now. We're gonna graph again. So we're gonna start by sketching this first problem, or number 3. Number 2, we're gonna sketch it. So forget all that other stuff for a minute and just get the sketch on. All right, so tell me, it says label all. I need to label my intercepts and my asymptotes. This one will not have a hole because nothing cancels, but it has asymptotes and intercepts. So here we go, shout them out. What do we know?
1 horizontal.
Horizontal asymptote is y equals 1. X over x. Perfect.
There's a vertical one at 2.
Vertical asymptote at x equals 2. Notice, kids, asymptotes are lines, and so when I label them, it's x equals or y equals. Perfect. What else do I know? X-intercept at -3 and y-intercept at -3/2. Perfect. Based on that, you should be able to sketch the picture. Pretty easy over here because you got points. They always follow their asymptote, so it gets closer out here and closer down here. And then the other half of the picture is this guy. Everybody okay with that? That's a very basic picture. I mean, there's nothing fancy or funky about that guy at all. But now we're gonna answer some interesting questions. These are limit questions. And as pre-calculus students, it is important that we have some sense of the concept of limit. What is a limit? D, that should just be a little negative sign. It should not be a -1. I don't know what I did there. Forget it. Cross out, that should just be a little negative sign on that. I need to fix that. All right. Now, in the limit LIM stands for limit. So in the limit notation itself, it tells you what's happening with X. In this first problem, X is approaching infinity. So on your picture, where does X approach infinity? Where is positive infinity on the X? Isn't it clear out here? Isn't this where X is approaching infinity? X now, so sideways, X approaching infinity. The question is, then what's happening to Y? What is Y doing as X goes to infinity? Well, as X goes to infinity, what is my Y value doing? What is happening to my curve? If I keep going, what's happening? Aren't I getting closer to 1? Isn't 1 like the limit? It's getting closer to 1. So we say the answer is 1. And then we put a little plus sign here, because when you approach 1, you can approach from the top, or you could approach from the bottom. So the top is the positive side. So this just means the farther right I go on my picture, the farther right I go, the closer my curve gets to 1 from the top. All right, what about this one? What is this one saying? What happens as you go left? Negative infinity? Well, what does happen as we go out this way? What is my curve doing? Aren't the Y's getting closer to 1 again? But this time, they're coming in from the bottom. So this would be 1 from the bottom. Right, now again, this tells you what X is doing. So what does this say? X is getting closer to 2. That little plus sign means from the right, no. For Y's, they mean top and bottom, because Y is vertical. But for X, they mean right and left. So if I'm 2, this is my positive side, and this is my negative side. Does that make sense to you? Okay, so what happens to my picture as I get closer to 2, here's 2, as I get closer to 2 from the positive or the right side? What's my picture doing? Going up where? Positive infinity. It's shooting up forever and ever and ever. Shooting up. Positive infinity means we're going up. Now what happens as we approach from the negative side or the left side? Here's 2. I'm approaching from the left side. What's happening to my curve? Going down. So when you're asked to look at a limit, evaluate a limit based on a graph, just look where it tells you to look. What happens as X goes right? What happens to my curve? Or what happens as X gets closer to the asymptote? Okay, that was easy enough. A little confusing maybe. Let's do 3. Let's try 3. So first of all, you want to draw your picture. Okay, so we're going to draw our picture. Would you agree no holes again? No holes, okay. So, what do we have? A vertical asymptote at -2, perfect. Yep, what else do I have?
A horizontal asymptote at 2.
Yep, we have a horizontal also at 2, because this time when we box them in, we have 2x over 1x. Perfect. All right, how about my intercepts? Y-intercept is 1/2. Because if you let x be 0, you get 1 over 2, right there it is. Where's my x-intercept? What makes the numerator equal 0? Wouldn't it be -1/2? Got an idea about this one, what it looks like? There's no holes, so I'm done. I gotta graph it now. I gotta sketch it in. What do you think? Are you good with that? And what's the other half look like? Remember, there's 2 pieces to this graph. Yep, it's up here like this. Perfect. So now, I think the questions are the same. Oh, no. All right, so here we go. Tell me what's happening as I head all the way right on my picture. That's what this means. This means keep going. What's happening if I keep going? I'm getting closer to 2 from the bottom. So we'll say I'm getting closer to 2 from the bottom. Now what about when I go right? Keep going this way, extend this arrow, keep going, going, going. What's happening? We're getting closer to 2 from the top. All right, now here's my asymptote, right here at -2. This says, come at -2 from the positive side, or from the right. So here's -2. As I get closer to it, on the right side, what is my pencil doing? Going down. So that one's going to be -infinity. See how that arrow's just going down, 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 down? Well, what's happening as I come at it from the left side? Here's the vertical asymptote. I'm coming at it from the left side. What's happening? Positive infinity. Okay, that notational stuff's a little bit new. We hopefully are getting, this means go all the way right on the picture, go all the way left on the picture. This means come at your asymptote from the right side, come at your asymptote from the left side.
I used to have them.
Yes, hurry up, leave your phone here. All right. Next problem, number 4. Got an idea. Factor, yes ma'am, I love it. So how does the top factor? Perfect, difference of squares. And how about the bottom? Uh-oh. What do you notice? We're going to have a hole. Our new equation is y equals x minus 3 over 3. That's all that's left. Would everybody agree with that? So that's what I'm gonna be graphing. Now, the fact that something canceled means I will have a gap, an open dot, a hole in my picture. The hole always happens at whatever x value got canceled out. So if this would have stayed in the problem, it would have been a vertical asymptote. And the vertical asymptote would have been at -3. Well, it's not there anymore. Now it's a hole, but its x-coordinate is -3. But the hole is not a line, it's a point. So I need a y to go along with the x. So how will I find that? I'll plug it in, and you plug it in right here, kids. Don't go back and plug it in the original, because it won't work. It won't work. You need to plug it in here. So what do I get if I plug in -3 for my x? I get -2. Which means in my picture, I have an open dot at -3, -2. Is there a vertical asymptote? No, because where do vertical asymptotes come from? Remember, this is your problem right here. Where do vertical asymptotes come from? The denominator. What makes the denominator 0? Well, nothing's gonna make the denominator 0 because there's no x's down there. So no vertical asymptote. What about horizontal asymptote? Well, so we would have to put 0 in the bottom because we have 1x over 0x. Can we do 1 over 0? No horizontal asymptote either. Okay, is there an x-intercept? Is there anything that would make the numerator 0? Yes, what is it? 3. And is there a y-intercept? In other words, can I let x be 0? Yes. And what do I get if I let x be 0? -1. Now there aren't any asymptotes to break this picture up. So I'm going to connect the dots. Well, what shape am I going to get when I connect these dots? I'm going to get a line, that's exactly. And I'm hoping you recognize that this is 1/3 x minus 1 if you rewrite it. And that's just a line with a y-intercept at -1 and a slope of 1/3 up 1 over 3. That's supposed to be a straight line. All right, here we go. Number 5. All right, what do you want to do first? Factor the whole shebang. All right, well, I find another marker here. Go ahead and start factoring. How does the top factor? Okay. Is that right? Yep. And then how about the bottom? You can pull a 5 out. And then you have the difference of squares. Is that okay with everybody? Uh-oh. Beep, beep, beep. What do you notice? I have a hole, gotta take care of that, kids, things aren't gonna work out very well if we don't take care of that. So let's take care of that first. This becomes my new problem. And I'm gonna have a hole where X is what? -1. Is that okay with everybody? What's my Y coordinate? I canceled this out, so that's why my hole's at -1. So now my numerator, if I put in -1, -6 over 5 times -2. I'm just plugging and checking, right? So I get 6/10, which reduces to 3/5. So my whole is at -1 3/5. All right, what else do I have? Well, I've got other stuff. I've got asymptotes and intercepts. So who sees something? Meg?
Vertical asymptote at 1.
Vertical asymptote at x equals 1. Perfect. Katie?
A y-intercept at 1.
Y-intercepts at 1. Very good. Let's make sure everybody's on board with that. She said my y-intercept's at 1 because if I put in 0, that's how I find a y-intercept. If I put in 0, I get -5 over -5, which is 1. You can also tell that one from the original, if you want. Perfect, beautiful. How about a horizontal asymptote? Does this guy have a horizontal asymptote? Y equals 1/5. You can get that from the original, or you can get that from here. And what am I missing? Oh, x-intercept. Do I have an x-intercept? I do. Where is it? 5? How do I get an x-intercept? Is what makes the numerator 0. That makes the fraction 0. So if I put in 5, I get 0. That's an x-intercept. It's called a 0 of the function. Can you sketch it? How can you go on to this? Well, the next one will be very exciting. But this one, oh, it's kind of a regular old picture. It's not too exciting. Does that look okay to everybody? When I sketch it in, does that make sense to you? If you ever can't figure it out, so let's say you had your points and things up there, but you really couldn't tell what it looked like, you can always set up a t-chart and plot some extra points. So for example, if I really don't know what's happening over here, then I can put in 2 and 3 and 4 and see what happens. You almost never have to do that once you get all this stuff graphed, but if you are confused, you can always get yourself out of it by plotting some extra points. Okay, we are all pumped up. We're ready for number 6. It'll be our last one we do today, but it is going to be a little bit different. It is going to have something new. You may have done it last year, but we have not done it together. All right, so here we go. We're going to graph this guy. What do we do first? You know, what do we always do first? Factor it. So it factors plus 4 plus 1. Well, nothing canceled, okay, that's all right. That just means I won't have any holes. All right, so what do I have?
A horizontal asymptote at one.
Now, actually, Jake,
Archie,
you picked the tricky one. There is no horizontal asymptote. We're gonna talk about that, that's the new part. But this picture isn't gonna have a horizontal asymptote because why? I got an x squared on the top, but no x squared on the bottom. Okay? Now, we're gonna talk about what that means in a minute, but let's get the other stuff in there. Do I have a vertical asymptote?
Yeah.
Yep, it's at 2. I have 2 x-intercepts. They are at -4 and -1. And I have a y-intercept, if I let all the x's be 0, I have a y-intercept at -2. Now, did I do any of that too fast? Did everybody follow along? There are no holes. There's no horizontal asymptote. There is a vertical. There are 2 zeros, 2 x-intercepts, and 1 y-intercept. Everybody okay to this point? Now, there's no horizontal asymptote, but there is what we call an end behavior asymptote. Horizontal asymptotes are special end behavior asymptotes. They're the easiest kind. If there's no horizontal asymptote, then to find your end behavior asymptote, you need to do this division. So you recognize this is this divided by this, right? So I'm going to do synthetic division. Out here in the box, this is what I'm dividing by. So what will I put in the box? 2. And across the top will be 1, 5, and 4. Now I'm going to do regular synthetic division. So that's what I got. Am I okay on my division? Okay. Now, this is never going to be 0 when you do this process. Because if it were 0, we would have been able to cancel the thing out. So you're always going to get a remainder. The good news is we don't care about it. Ignore it. The remainder is not important. What's important is the quotient. So keep in mind you divided into the original was x squared. So what does this stand for down here? X plus 7. That, my friends, is your end behavior asymptote. The quotient right here is your asymptote. So what does this asymptote look like? It is not a horizontal line. What is it? It has a slope of 1 and a y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7. And a slope of 1. There's my end behavior asymptote. So to find it, I literally divided. That's it, I divided. Ignored the remainder and took the quotient. That's my end behavior asymptote. Now what in the world does this look like? Well, your asymptotes are crossing right here. Can you sort of see kind of a shape down here maybe? Something like that, following those asymptotes here? where do you think the other part of the picture is? Yep, right up here. I don't have much room, but it's right up there in that little space. Because when we graph these, aren't the two pieces across from each other? This time, they're across from each other diagonally because of the slant asymptote. This is sometimes referred to as a slant asymptote. Okay? Oh my gosh, we learned something today. All right, one more quick comment and then I'll shut up. Do you understand that it would be possible, depending on the problem, for this guy down here to actually be x squared plus 5x minus 8 or something? That depending on what I started with, this could be an x squared? So talk about mind-blowing. Your asymptotes don't have to be lines. Your asymptotes can be parabolas, which is very much fun. All right, I'm gonna go ahead and hand out some review material. This section only has this little unit